So the first problem asks us to look at height as a function of time for this roller coaster. And so if you think about what happens in a roller coaster, we know that a lot of time is spent just trying to get to the pinnacle of the roller coaster. And it's a pretty constant pull up using some form of a chain system. So when I'm going from A to B, I'm just constantly going upward um, at a steady rate. When I get to B to C, it's still typically at that same pace because it's flat up top and it's just letting me coast until I go over C. And this is where things start to change a little bit. If you look from C to D, at the beginning I'm going to be going a little bit slower, so it'll take me a little bit longer to travel. But as I get closer to the bottom of it, I'm going faster and faster, and I'm traveling further distances. The height's changing faster, so very little time is passing. So you've got this almost curve that's getting closer and closer until it hits D, and then it goes and inverts the opposite direction, so that from C to D and D to E is very similar, like they're very symmetric around D, but it's got that curve inward. It's almost like the opposite. If you think about a quadratic function, how it curves outward, this curves inward. Same thing then from E to F, and then F to G, and then G you flatten off, so then you're going to go that slower pace again because you're going at that flat location. Now, then when we get to the second question, as you could look at speed as a function of time. So again, it's going to take a little bit to get started, and then you're going to go a constant speed pretty much all the way until you get to C. And then from C, your speed is going to quickly pick up, but at the beginning it's going to go a little bit slower, and then the speed's going to pick up until it's at the fastest point at point D, and then it's going to have fast speed, but it's going to continue to slow down as it gets to E, and then as it goes around E, it's going to speed up again. F to G is going to slow down, and then from G to H, it's going to slow until it stops, because the roller coaster does have to stop at some point. So when you think about speed at A and H, it should end on the x-axis, because speed should be 0 when you begin and when you end. And again, you have this, what I would call like that inverted curve happening on these points because of the fact that it amount of time it takes within those places. So then when you get to question 3, asking you to examine how is the roller coaster similar or different, why is it different than what you see? Why does this graph look different than the actual roller coaster? And again, it's about that you're focusing on time. The height, and you may have some similar features, but think about it, your A to B is being exaggerated because you're focusing on the time. Your curves on C to D, D to E, E to F, and F to G are actually going to take the opposite curve than what it does in a roller coaster, because in a roller coaster, you always come more like the parabola. I mean, you look at this curve, it's very much like a parabola, whereas here it's curving inward. So it takes that opposite curve as well because of what's happening with time and how your time is being shrunk as you get faster. All right, so when we think about then the two graphs, the way they're constructed, they are different because here you're focused on height. So in this one you're focused on speed. So they are almost like opposites of one another in what's going on, because at your lowest height is your fastest speed because you've come down the hill at that point. So there is some relationship between those two within what's going on. And last question there asked about, does these graphs represent a function? Well, if you think about how the graphs look, and we think about the idea of, well, what's going on, there's no time, say in the height, where that at that specific time I'm at two different heights. So if I think about a vertical line test, I will pass the vertical line test with the graph that I've constructed. And the same thing here. There's no way that I can be at two different speeds at the exact same time. So both of these graphs represent functions as well.